secant. Does that make sense?
Yeah.
Right. So now remember, derivative of tangent is secant squared. I'll write this down so you can see that it is a negative du over u, which is negative the integral of 1 over u du, which is the negative natural log of u, plus c. So do you remember this Pythagorean identity?
Yep.
And do you remember this derivative?
Yep.
All right, so now what we're going to do is use these to find, only Megan remembers them. But anyway, let's take tangent squared, and we're going to rewrite it as secant squared x minus 1. And we are going to now separate the integral. You don't have to, but sometimes it just makes it easier. Now, what is the integral of secant squared x? Tangent squared x, or tangent x. This right here. If we're taking the integral, it goes back to it. Minus x plus c. And we're done. Oh, now this one is a tangent cubed. So we're going to separate it to tangent x times tangent squared x dx. And I'm going to actually write this as tangent x secant squared x minus 1. This is very similar to when we did the sine squared plus cosine squared equals 1. And now I'm going to distribute, so I have tan x secant squared x minus tan x dx. Alright, so I look at this one. Any ideas? Well, let's look at u equals tan x, du equals secant squared x dx. Does that look like u du?
Yeah.
So I'm going to write u du minus the integral of tan x dx. Well, what's the integral of u?
1/2 u squared.
So I'm going to go 1/2 tangent squared x. Now we just did tan x, didn't we, up here at the very top? Didn't we go up here? So instead of redoing it again, I'm just going to say minus the natural log of whatever my inside is, secant x plus c. This one came up from the very top, and now we're done. So far, so good? That's what we did up here.
Yeah, no, but I have never.
Nope, because we didn't do integral of tan x. We might have done, nope. I know. But now we have, so now we know. What do you want to do with tan squared, or tan fourth? Split it up. So tan squared x times tan squared x dx. What do we know tan squared equals? What Pythagorean? But this is multiplied, so you can't do it that way. You have to keep separating it. Keep going. Now this time I'll multiply it through. Yes.
Can you not just do secant squared x minus 1 times secant squared x minus 1?
Well, then I end up without a tan, and if you remember up here, that allowed us to use the u substitution. We don't know the integral of secant squared x. So if I keep the tan in there, I can actually do my u substitution. All right, so now what I have is u squared du minus, do we know what tan squared x is? The integral of this? Yeah, didn't we do it in example 1? So I'm going to write down minus this whole thing plus c. No, it wasn't tan squared x up there. So now I have 1/3 u cubed, which is tan cubed x minus tan x plus c, x plus c. So instead of having to redo each individual one, we just use the previous information. Make sense? All right, we've only got 3 more to go. If we did cotangent, what do you think's next? Cotangent. All right. Now I'm going to write down here, cotangent x happens to be cosine x over sine x. Right? And if I put u equals sine x, what does du happen to be? Cosine x dx. So if I take this and rewrite it, I end up with this being du over u. When I integrate that, I get the natural log of u. U happens to be sine x, so here is the integral of cotangent x. Okay? It's easier than the tan one because you had to add the negatives in there. So remember, what's the derivative of cotangent? Negative cosecant squared. And then there's this Pythagorean identity. That's where these identities come in handy. As much as you hated them in pre-calc, they make the integration so much easier. Okay? So now I have cotangent squared. I'm going to rewrite this as cosecant squared x minus 1 dx. So far, so good? Well, let's see. What's the integral of cosecant squared? I need a negative in there. Do I have a negative? Nope. So what about if I do this little trick here? Negative, negative. And then I'm going to do this. What's a negative times a negative?
Positive.
So I didn't change anything. I just changed the way it looks. So what's the integral of negative cosecant squared? This part right here. Cotangent x minus x plus c. This part here is tangent, but there's a negative in front. Say that again? I certainly can. All you had to do was say so. Okay. Can't hear everything. I might be a mom and I might have eyes in the back of my head, but my ears aren't as good as they used to be. Just don't yell at me. All right, cotangent x times cotangent squared x dx.
Oh, I see you. I was thinking, I was like, I swear, just don't look at Muncie because I had something to tell you.
I have 4 arms. One of them is holding the camera for me.
Okay.
All right, what's cotangent squared equal to? We haven't integrated yet. We're just replacing the identity. Now I'm going to say u equals cotangent x, du equals negative cosecant squared x dx. So I multiply this out. This one's got a negative, but this one doesn't. So I'm just going to put negative du, and I'm going to substitute u du negative. Does anybody know what the integral of cotangent x is? Look at the top of the page. No, it's a derivative. What's the integral? This integral isn't too bad. Negative 1/2 u squared minus the natural log, the absolute value of sine x plus c. Do you see how this all kind of builds upon the other stuff?
Yes, I do.
Very last problem.
Woohoo!
Very last one, and then we'll answer any homework questions. We're going to separate it again. Notice you want to get squares because then you can look at the Pythagorean identity. So So I'm going to put cotangent squared x cosecant squared x minus 1 dx. Multiply it through. Do we know the integral of this one? Yeah, we did it in example 4. So it's going to be minus negative cotangent x minus x plus c. Why did I put the plus c on the outside? Because it doesn't matter if I subtract it or add it, it's still just a constant. All right? Well, let's see if we can do some u substitution again. U equals cotangent x. Du equals negative cosecant squared x dx. Negative du equals cosecant squared x dx. This right here is my negative du. This right here is my u squared. Take out my negative. What's the integral of u squared? Ta-da!